In this lesson, we're going to look at rational expressions. Previously, we've been talking about polynomials, terms with variables and numbers. The variables have exponents, which are whole numbers. We've been practicing factoring them to break them down into smaller components with multiplication, and then with equations, being able to solve those equations for the variables. Now we move into rational expressions where we're going to look at a polynomial divided by a polynomial. A rational expression is an expression of the form a over b, where a and b are polynomials and b is not equal to 0. Remember back in previous classes, we can never divide by 0. Dividing by 0 is not allowed. Let's take a look at some examples of rational expressions. Here, this first one, 3x minus 12 divided by x squared plus 2x. This is a rational expression because the numerator, 3x plus 12, is a polynomial. It's actually a linear polynomial. And the denominator, x squared plus 2x, is a polynomial. It's actually a quadratic polynomial. For this expression, we're going to evaluate it for x equals 1. That basically means instead of the x in the rational expression, we're going to replace the x with 1 and then simplify it. Up top in the numerator, we have 3 times 1 minus 12, and in the denominator, 1 squared plus 2 times 1. We can simplify those numbers, multiplying by 1, and then do that subtraction, 3 minus 12, negative 9. 1 plus 2 is 3, and then the division, negative 9 divided by 3 gets us negative 3. So if x equals 1, and we have this rational expression, 3x minus 12 divided by x squared plus 2x, if x equals 1, the rational expression is negative 3. We can do this for the next two values as well. 3 times 4 minus 12 divided by 4 squared plus 2 times 4. On the top, 3 times 4 is 12. On the bottom, 4 squared is 16. 2 times 4 is 8. And then check out what we have here. 12 minus 12 is 0. 16 plus 8 is 24. But 0 divided by 24, 0 on the top is okay. We can think about this as if I have 0 apples and I want to divide them into 24 groups, how many apples per group? There are 0 apples per group. Let's try x equals 0. So 3 times 0 minus 12 divided by 0 squared plus 2 times 0. On the top we get 0 minus 12, and on the bottom 0 plus 0. So we have negative 12 divided by 0. And like mentioned previously, we cannot divide by 0. We could think about it this way. Let's say I have 12 apples. How many different apples per group if I divide those 12 apples into 0 group? If I have no groups, then I can't divide the apples into groups. It's not possible. Dividing by 0 is considered undefined. And then one more example for this rational expression. X is 1/3, so we'll plug in 1/3 in for x. 1/3 plus 2, squared, 2 times 1/3. This one gets a little bit tricky because of those fractions, but we can make them work. 3 times 1/3 will give us 1. 1/3 times 1/3 is 1/9. 2 times 1/3 is 2/3. I'm going to focus on the denominator here, 1/9 and 2/3. I need a common denominator. So I'm going to multiply top and bottom by 3. And then on the top, negative 11 is just going to stay there. Done off to the side. I need a common denominator in order to add these two fractions together. So I am going to multiply this second fraction by a special form of 1. 3 divided by 3 is 1. But now, if I multiply 3 times 3, I get a denominator of 9, which will allow me to add the fractions. So adding and subtracting, we have to have same things. And so multiplying up top, 2 times 3 gives us 6, and 1 plus 6 on the top is 7, so 7/9. I'm going to replace that over here in my writing. -11 divided by 7/9. If you remember your division of fractions, which we are going to talk about a little bit later, I copy, dot, flip, and -11 is a whole number, so I'm going to write that over 1, multiply straight across. -99/7 is actually what happens when we plug in 1/3 for x. Let's try another example, another rational expression. 3x squared plus 8x minus 3 divided by x squared minus 5x plus 4. And again, we're just plugging in numbers for x and simplifying. So the first box, we're going to use the same numbers we did before. X equals 1. So let's plug in 1 for x. 1 squared, 8 times 1 minus 3 divided by 1 squared, 5 times 1 plus 4. And let's simplify. So 1 squared is 1, 1 times 3 is 3, 8 times 1 is 8, and on the bottom 1 squared is 1 minus 5 plus 4. Simplifying the top, 3 plus 8 minus 3 will give us 8. 1 minus 5 plus 4 gives us 0. 8 divided by 0, which we talked about, dividing by 0. 0 on the bottom is undefined. Let's see what happens when we plug in 4 for x. 3 times 4 squared plus 8 times 4 minus 3. 4 squared, 5 times 4 plus 4. 4 squared up top is 16. 8 times 4 is 32. 5 times 4 is 20. 3 times 16 is 48. 16 minus 20 plus 4. That's going to give me 0 on the bottom. So 48 plus 32 minus 3. I get 80 minus 3, which is 77 divided by 0. But I can, because I'm dividing by 0, just to go ahead and skip down and write undefined there. I'm dividing by 0 and I'm not allowed to do that. Plugging in 0. Notice on the top we have 0 plus 0 minus 3, and on the bottom 0 minus 0 plus 4. We get -3/4 in our simplification. And we can try the 1/3. 3 times 1/3 squared plus 8 times 1/3 minus 3 divided by 1/3 squared. 5 times 1/3 plus 4. 1/3 squared is 9. 8 times 1/3 is 8/3. And we can simplify these fractions. 3 and 9 I can simplify a little bit better. I get 1/3 plus 8/3 minus 3, so I get 9/3 minus 3 over some stuff on the bottom. I'm going to multiply that 5/3 by 3 again. 3 on the top and 3 on the bottom. Same with the 4, 3 on the top, 3 on the bottom. In this case with the 4 I need 9 to get a common denominator. On the bottom we get something like 22/9. But on the top, 9/3? Well, 3 minus 3 gets a 0 on the top, and 0 on the top is okay. We end up with an answer of 0. For all of these examples that we just did, plugging in these numbers, when do we see undefined come up? Well, we see undefined here, and here, and here. What do these three examples have in common? We're dividing by 0 for each one. So we say a rational expression is undefined when the denominator is 0. We will talk about when a rational expression is considered undefined. We already know 2 values for the second example of rational expressions, and we know 1 value for the first rational expression. But let's see how those values are connected to our factored form for these expressions. So for the first rational expression, 3x minus 12 over x squared plus 2x. Notice it's the same rational expression we used for the first example. Let's factor the denominator. So we're factoring the denominator. We don't really care what happens with the numerator. Just the denominator, factor it out. X squared plus 2x. We can factor out the common x, and we get x times x plus 2. We just determined a rational expression is undefined when the denominator equals 0. We're going to solve this equation. The denominator equals 0. Now remember from our previous work, if we have a power for x, x squared, the way that we solve it right now is by factoring. So let's put in our factored form. X times x plus 2 equals 0. And then we apply that zero product property that says if we multiply two things together and the product is 0, then one of those things must equal 0. So we set each one of them equal to 0. X equals 0, x plus 2 equals 0. And then if we need to, we solve for x. So this one's already solved, x equals 0. In the second one, we can subtract 2 from both sides so that we can eliminate the plus 2 on the left and get x by itself, and we get x equals negative 2. So we have two answers where this particular rational expression is undefined. It's undefined when x equals 0 and x equals negative 2. And sure enough, looking at our previous example, x equals 0 caused that rational expression to be undefined. We did not test negative 2, so we didn't see the negative 2 right away. Okay, let's try to factor the second's denominator, or the second rational expression's denominator, x squared minus 5x plus 4. When we're looking at this one, a is 1, b is negative 5, and c is 4. We need two numbers that multiply to be a times c and add to be b. Two numbers that multiply to be 4 and add to be negative 5? Well, negative 4 and negative 1. So we can factor x squared minus 5x plus 4. I'm just going to focus on that denominator because that denominator is the important part for finding where a rational expression is undefined. We found our two numbers, negative 4 and negative 1, give us negative 5. So I can substitute those in for negative 5x. I get negative 4x minus 1x. It does not matter in which order you put negative 4 and negative 1. If you switch them around, you'll end up with the same two factors. And we had talked about that before. So let's factor by grouping. X squared and 4x have an x in common. X times x is x squared. X times negative 4 gets us negative 4x. Whatever sign is in the middle, we bring it down. And then x and 4 have only 1 in common. So let's pull out a negative 1, factor out a negative 1. And now once we have that factored out, we can pull out what they have in common, x minus 4, and then write in the leftover bits, x minus 1, and we have our factored form. Now to show where the expression is undefined, x squared minus 5x plus 4, the denominator, equals 0, and we're going to replace the denominator with our factored form, x minus 4, x minus 1. And just like before, using that zero product property, x minus 4 equals 0, x minus 1 equals 0, and then solve those equations. So I can add 4 to both sides on x minus 4 equals 0, x equals 4. And on the second one, I can add 1 to both sides, and I get x equals 1. We have our undefined values, x equals 4, and x equals 1. And notice here, when we did our examples above, x equals 1 and x equals 4 gave us our undefined values for x.